This is quiz number 1 from spring 2010, and it's problem number 4, called Deja Vu. So this problem concerns a combinational device that computes the function of 3 variables, a, b, and c, which is not c or a and b. And we'll represent this using a new gate symbol, which is shown here. And it says the function may have a familiar ring to it. So, part A says, can this device be implemented as a single CMOS gate? So we remember that we have some collection of PFETs up top, some collection of NFETs in the bottom, an output, some inputs, right? Power and ground when we have a single CMOS gate. When all the inputs are 1, all the inputs are going to conduct, so the output should be 0. This is an entirely inverting function, so we should be able to implement this as a single CMOS gate. We can go ahead and just draw it out. We have this whole not thing, so we can design the NFETs first. We have C, OR, so C is going to be in parallel because it's OR. It could be this side or this side. A, B, right? So complementary PFETs, we just make the C in series with the parallel A and B. Now, that's output, right? So it looks like we can do this with a single CMOS gate with 6 transistors. Suppose we connect 2 F gates in a 3-input acyclic circuit as follows. In the following, assume the following timing parameters for each F gate. So we have a TPD of 5 nanoseconds, and then we have a TCD of 1 nanosecond. And it says, give the appropriate specifications for the propagation and contamination delays of the entire above circuit. So we're being asked about this whole thing. So we know that propagation delays are additive along the maximum path, right? So the maximum path is through 2 of these. So the propagation delay is going to be 10 nanoseconds. And for the contamination delay, we want to go along the smaller path, which is only through 1 of these. So in this circuit, the contamination delay adds to 1 nanosecond. So now problem C is asking us for a simplified Boolean expression in terms of W, X, and Y for the output of the given circuit. So I've labeled the 2 parts of it as F1 and F2. So we know that F1 is going to be not something and something or something, right? So the something and something are on the same edge, so that's W, and then or X. So W and W, that's W. So this gives us as F1 simplifies to NOR of W and X. Now F2, right, is negation of F1 and X. Those are the 2 things coming on the flat side to the left, or Y. Now, if we plug this in, we get F2 is, we have neither W nor X and X in that, or Y. So if we have neither W nor X right here, and X, that's impossible, right? Because X has to be 0 for this to be true, and X has to be 1. So this is going to simplify to a big fat false, or 0. So if we had 0 or neither 0 nor Y, we know that, 0 can make this nor true, but Y has to be, so it's not Y.